So far we have seen and understood that BGP contains various attributes that are attached to the path which influences the path selection process. We'll now have a look at various attributes and also go through the BGP path selection process that will help us understand and troubleshoot any issues with the path selection. The very first criteria when troubleshooting BGP path selection process is to understand if the router has a longest prefix match. If there is a longest prefix match available, that will be the first preferred mechanism to select a best path. If there are summarized prefixes and if there are more specific prefixes present in the routing and the BGP table, by default, the longest prefix match will be the one that will influence the path selection mechanism or make the route a best path in the BGP table. BGP recalculates the best path for a prefix upon 4 possible events. BGP next hop reachability change, if the next hop has actually changed for the prefix that is there in the BGP table. Failure of an interface connected to the eBGP peer. If there's a link flap or an eBGP connection that has gone down, that influences the path selection mechanism. If there's a redistribution change, if you are redistributing few number of prefixes and if you modify the route map when you're trying to redistribute, that will still influence the path selection mechanism based on what you're redistributing. Also, the path selection mechanism kicks in on the reception of new path for a particular route. Say for a path is already present for the prefix 100.1.1.0/24, but if you inject another path for the prefix 100.1.1.0/25, it will influence the path selection mechanism for the prefix 100.1.1.0/24 and 0/25. In this topology here on the screen, we can notice that there are 2 routers which are at the edge of the enterprise network, router 1 and router 2. Both are advertising the /25 prefix of the same subnet which has, and some are also advertising the summarized subnet of the same subnets. So say here we have 100.1.1.0/25 and router 2 is advertising 100.1.1.128/25. But at the same time, both of them are also advertising 100.1.1.0/24 from both the routers. What will happen is the best path will be selected on both the routers for the /25 subnet they are advertising. But if any of the router fails, the traffic will be switched over to the backup path. So say for if router 1 fails, the traffic for the subnet 100.1.1.0/25 will be switched over to router 2 where it's also advertising 100.1.1.0/24 because it is a part of the same subnet /24 subnet, and this /25 subnet is part of that subnet itself. Thus, there won't be any traffic loss with this failure event on router 1. It is also important to understand the BGP path selection algorithm influences how the traffic enters or leaves an autonomous system. BGP does not use metrics to identify the best path in a network. BGP uses attributes to identify its best paths. BGP installs the first received path at the best path automatically. When additional paths are received, the newer paths are compared against the current best path. If there's a tie, then the processing continues on to the next step of the path selection algorithm. Let's now walk through the different path selection algorithms that we have with BGP. The first one is wait. Wait is router-only attribute. Its scope is just towards the router. And if there's a wait for a prefix which has a higher weight than the prefix which has a lower weight, based on both the paths, the one with the higher weight value wins and will be selected as the best path. Local preference. Local preference has a scope of within the AS number. It influences the path selection mechanism based on the path which has the higher local preference assigned for a prefix. It is configured on the inbound direction and it influences the outbound traffic from within the AS. Locally originated. Network or redistribute command are preferred over the local aggregate command. Aggregate command is used for summarization. So if you are summarizing and if you also have a network command or a redistribute command, then the network or redistribute command will take the preference over the aggregate command. AIGP, Remember, the older path selection process or older path selection algorithm does not have AIGP part of it. The AIGP was introduced in the path selection mechanism or the algorithm later when AIGP was introduced. AIGP uses or has the scope of the IGP metric. You can use the IGP metric towards the next hop to be added as a metric and influence the best path selection algorithm. Whichever has the better metric, that path will be selected as the best path. AS path. Shortest AS path wins. If there are two paths, one with AS number 100, 200, 300, 400, and we have another AS path which is being learned via 100, 300, 500. The one with the lower AS path numbers in the list will be selected as the best path. Remember, the best path selection algorithm for the AS path is ignored if BGP best path AS path ignore command is configured on the router. That means it is not going to take into consideration the AS path list in order to influence the best path selection. There are other criteria as well. AS set, if it counts as 1, and if there is confederation, then it is not counted at all. And the confed part does not count. Confed means confederation. If you have confederation and you have multiple different AS paths, sub-AS paths within the confederation, those AS paths won't count. Origin. What is the origin of the route? The IGP is preferred over EGP, and the EGP is preferred over incomplete path. And thus, the lowest value wins. MED. MED stands for multi-exit discriminator. This value is assigned for paths which are outbound of the AS number, compared only if the first AS in the AS sequence number is same for multiple paths. If the AS sequence number is different for the paths received for the same prefix, then MED might not come into play. Remember, the difference between AS set and AS sequence number is AS set is an unordered sequence of the AS paths, whereas AS sequence is the ordered sequence of the AS path numbers for a particular prefix. eBGP over IBGP. External paths are preferred over internally learned paths. This is by default behavior. Metric to next hop. Depending upon what is the IGP cost to the BGP next hop, the lowest metric wins and the best path is selected. If there are two paths, two IGP paths to the next hop, and one has a better cost than the other one, the first one wins and the best path is selected based on that. Multiple paths in the RIB. If there are multiple paths in the RIB, or you have maximum paths command configured under the address family to install multiple best paths into the RIB, then all those best paths based on the number of best paths allowed will be installed in the routing table. Oldest external wins. If both paths are external, prefer the oldest received path. Based on which path was received by the router first, that path will be selected. And remember, all the first 1 to 10 criteria should be ignored before or should be same in order to move to this criteria. It holds for all the rest of the criteria before and after. If criteria 1 is matching and criteria 2 is having a preference, then criteria 2 wins and the next step in the path selection algorithm is not followed. BGP router ID. Based on which router has the lowest BGP router ID, the path learned from that particular router ID is selected as the best path. Cluster list. Remember, cluster list is specific to route reflectors only. The path with the shortest cluster list always wins. Neighbor address. If all the criteria are matching from 1 to 13, then the only tiebreaker criteria would be based on which neighbor has the lowest neighbor address configured in the neighbor statement is selected as the best path.